Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be learning of how to name parts of circles. So let's go ahead and let's start by taking a look at what we have written here. So what is a circle? A circle is a locus or set of all points in a plane equidistant from a given point called the center. Now that seems really wordy. All it means is that if you're given a circle like we have here, it doesn't matter what point you pick on the circle, it's always going to be the same distance away from the center of the circle because it's perfectly round. So how do we name a circle? Well, sometimes we put a circle with the center next to the letter. So that's circle C. Or we could literally write out circle C. That's another option, is to write out circle C. Now, what is a radius? A radius is a segment with the endpoints at the center and on the circle. So, to get the radius, we have to start at the center of our circle and go outwards. So, CF is a radius. CE is a radius. CD is a radius because they start at the center and go outwards. So we just name those like we would segments. So when I write out my segment, I put the center of my circle first and then the point that's on the outside. So I also have CE and CF. So all of these are starting with C. So we're putting the C's with each of those. Next, it says a chord. A chord is a segment with the endpoints on the circle. So now it doesn't matter about the center. Okay, we just need to have both of the endpoints be on the outside of the circle. So segment AB is a chord. Segment DE is a chord. Okay, now let's take a look at a diameter, a segment with the endpoints on a circle. Okay, that's the definition of a chord. So a diameter is a special version of a chord. Okay, that goes through the center, okay, but it's a chord that has to go through the center of the circle, and it's made up of two radii. So DE is our diameter. So what do we notice about DE? We notice that it's a chord because it goes and it has an endpoint on both sides of the circle. However, it's also a diameter because it goes through the center. It's made up of the radii CD and CE. So that's the definition of a diameter. So let's go ahead and name a few things looking at a circle. So for letter A, for number 1, we're trying to identify the parts of these circles. So what's the name of the circle? It's always named by the center. So since the center is P, I'm going to draw a circle with a dot in it, P. So the name of this circle is circle P. So let's name some radius. So some radii. The radii extend from the center out to the side. So all of these in orange are our radii. So PN is a radius, PM is a radius, and PL is a radius. Next, it asks us to find the diameter. Now remember, the diameter needs to touch both ends of the circle and go through the center. So this line right here is our diameter. So I'm going to name that line LN. Last but not least, let's take a look. Now we want to find just a regular old chord. So we need to find a line that has two endpoints, okay? Or two endpoints on the outside of the circle, and that's MN. So the line MN is a chord. Let's take a look at letter B. So for letter B, we want to name the circle. So again, we're going to look at the center of the circle, which is E. So circle E is the name. Now, to find some radius, we want to see what extends from the center of the circle on outwards. So that's EH, EF, and EG. So EH, and again, we put that line over it because it's a line segment. EF and EG. Now, our diameter needs to go through the center of the circle and contain two radii. So that's going to be HG because it spans the entire length of the circle through the center. And a chord doesn't have to go through the center. It just has to have two endpoints on the outside of the circle. So that's going to be line JK for our answer for letter B. Now let's take a look at letter 2. Or number 2, sorry. If QV is 4, so if this is 4, QV, I notice, is a radius. What is the diameter of Q? Well, we know that a diameter forms two radius. So let's call this point L. So QL also has to be 4. So 4 plus 4 is 8. So the diameter is double in length of the radius. Now, if TU is 14, so the length of this whole thing is 14, what is the radius of circle Q? So all you're going to do is if this whole thing is 14, that whole line, to get the radius, you're just going to divide the diameter by 2. And 14 divided by 2 is 7. So the radius then is 7 in circle Q. Now let's take a look at the way circles can interact. So, congruent circles. In order for circles to be congruent, your radii have to be congruent. So this guy here needs to be congruent to this guy here. So we can write out a statement. Since GH, that line segment, is congruent to the line segment JK, which is the radius of the other circle, then we can say that circle G, because remember we name it by the center, is congruent to circle J. Now let's take a look at concentric circles. So that means it's a circle within a circle. So coplanar circles that have the same center. So we have a circle inside of another circle. Both of them have that center of A. That's what makes them concentric circles. So circle A, the first one, has a radius of AB. The second circle, so the other one that's also named circle A, but that one has a radius of AC. So we have AB and then we have AC for our two radii of the very two circles. Okay, so let's take a look now at the intersection of circles. Okay, so it's not showing up here. Awesome. So for the first one, you'll notice that you have two circles like this. They're intersecting here and here. So that's 2 points that they're intersecting at. For that first one. For the next one, you have two circles that are kind of touching each other, just in one spot. So those are only intersecting at 1 point. So we're really just looking at how many points those circles are crossing. So this is no points, but there's another way you can have no points. So concentric circles actually have no points of intersection. So that's the different ways that circles can interact with each other. They can either touch at 2 points, they can touch at 1 point, or they can touch at no points. So let's take a look at some intersecting circles. So take a look at your drawing. Okay, so you have a circle, and then you have a larger circle here. Wow, this is why teachers never draw circles, they put diagrams. So you have here, and you have this circle as center S. Okay, this one has center R. So notice that our diameters and our radii run into each other. This intersection point is point C, and this intersection point is point D. So let's take a look at what we know. The diameter of S is 30, so this entire thing is 30. So what's half of it? This length right here is 15. So what I'm going to do is I'm going to kind of draw a number line. So I have R, and then I have this next intersection point is C, my next intersection point is D, and S. So what I noticed first is that my radius from S to the edge of the circle goes all the way to point C. Goes all the way to point C from here to here. So that point is going to be 15. So if we go from S to C, it's going to be 15. Okay, so it's going to be 15 for that distance there because that's half of the diameter right there. Then it also gives us that DS is 9. So it gives us then that this length in here is 9. And it wants us to find CD. We'll call that length X. So then we know that X plus 9 is equal to 15. Subtract 9 from both sides, and you end up getting that X is equal to 6. So the length of CD then is 6 units. Let's take a look at this last one. I probably have to draw it again. Yep. Okay. So we're going to do a big circle, and we're going to have the diameter, and it's starting at X. There's my radius right there. And then we have another circle coming on in, and it's going to start with Y, again, with our radii overlapping. So again, I'm going to create a number line. Okay, this intersection point is W, this intersection point is Z. So I'm going to create my number line here. So I have X, and then I have W, and then I have Z, and then I have Y. So it gives us that the diameter of X, this whole thing, is 22. Well, the XZ is the radius of X. So XZ is the radius. So that's going to be half of the diameter. So to go from X to Z, it's going to be 11 because it's half of the diameter. Then it says that the diameter of Y is 16. So if we were to take Y and go all the way across, this would be 16. But that means that YW is going to be 8. Then it also tells us that WZ, that length right there, is 5. So what does that tell me? That tells me that I have an overlap of 5 units. So here's what I'm going to do. I'm going to just get rid of that overlap part. So if I take 11 minus 5, I get 6. So XW is 6. WZ is 5. Now I just need to figure out ZY. Well, to figure out ZY, I'm going to take 8, and I'm going to subtract off that overlap of 5, which is 3. The question is asking us to find XY, this whole thing. So now all I have to do are add up those 3 values that I have. So 6 plus 5 plus 3, and that's going to be equal to 14. Okay, so it's 14 units to span from X to Y. So that concludes your note video today. Show me your note sheet when you're done. Thanks for listening.